Hi students, in the previous video we have seen about the energy audit and what are the various objectives of the energy audit and what are the different types of the energy audit like that. So in this video we will see about the energy index and cost index and pie charts and load profiles. So energy index. So what is meant by energy index? So before going to the energy index, let us see the some lines regarding about the energy. So energy may be purchased in various units. For example, coal in tons and gas in cubic feet and oil in gallons and electricity in kilowatt hour, etc. But the relevant conversion from one system to another system and on a common base is to be done by using the conversion factors. So energy index is useful parameter to monitor and compare the energy consumption of the specific products manufactured by the industry. So the energy index is nothing but the index how much energy we consumed in overall. The index which gives the how much energy we consumed overall is nothing but energy index. So energy index is the figure obtained by dividing the energy consumption by the production output. So energy index may be calculated weekly or monthly or annually. Our wish, based upon our wish, we can calculate this energy index and every week or every month or annually. And what is meant by energy index? Energy index is nothing but obtained by dividing the energy consumption by the total energy consumption by the production output. The total energy indices are sufficient for monitoring purpose, but a record of the individual energy indices helps in identifying a particular sources in the event of increase or decrease in the energy index. So calculating the energy index, one example. So here one industry, three energy forms are there. What are the three energy forms? Oil, gas and electricity. So the annual energy consumption is shown below in various energy units. So for oil 14.2 into 10 cube gallons, and for gas 5 into 10 cube therms, and for electricity 99.5 10 cube kilowatt hours. And if the company produces total output, if the company produces 100 into 10 cube tons of a particular product, then the energy index will be. So we know the conversion formulas. 1 gallon is equal to 131.74 into 10 to the power of 6 joules, and 1 therm equal to 1.055 into 10 to the power of 8 joules, and 1 kilowatt hour equal to 3.66 into 10 to the power of 6 joules. So the oil content is 14.2 into 10 cube gallons, and the gas content is 5 into 10 cube therms, and electricity content is 99.10 cube. So these gallons will be converted into joules, and these therms will be converted into joules, and these kilowatt hours will be converted into joules. How? By using these factors. Then this will be representation of the energy completely in one unit. That unit is nothing but joules, and we can change these joules into watt hours also by using this formula. 1 watt hour equal to 3.6 into 10 to the power of 6 joules. So what is meant by the energy index? What is meant by the energy index? Energy index is total energy divided by the output. So what is the output? 100 into 10 cube. 100 into 10 cube. So energy is for oil 0.520 into 10 to the power of 9 divided by 100 into 10 cube. And similarly 0.146 into 10 to the power of 9 divided by 100 into 10 cube, and 0.0995 into 10 to the power of 9 divided by 100 into 10 cube. So we get the energy indexes for individual components. That means for oil energy index, and gas energy index, and electricity energy index. And what is the percentage of this one? That means we can add all these, then we get the total value. So this amount 5.2 into 10 to 10 cube divided by the total value will give the percentage of the energy balance of the oil, and 1.46 into 10 to 10 cube divided by total energy into 100 will gives the percentage of the energy balance for gas, and similarly we can get the 13.0 percentage of the energy balance for electricity also. And in the similar fashion we go for the cost index also. Up to now we see about the energy index, how much energy we consumed per a month or per a week or per a year is nothing but the energy index. The energy index is the total energy consumed divided by the total output products. So now cost index. So cost index is the another parameter which can be used to monitor and assess the energy consumption by a company. So here we can verify our consumption in point of view in the point of cost. Then that is called the cost index. So it is defined as the cost of energy divided by the particular product. Divided by the particular product. So the cost of the energy and how much product is. How much product is. So an individual cost index can be determined for each energy form and for the total energy cost consumption by the company. By adding all those, we can get the total cost index. So the table shows the energy cost of a company using coke, gas, and electricity. So this company produces 15 into 10 cube tons per year. So calculate the cost indices. Means for coke, energy consumption is 1.5 into 10 cube tons, and the cost for that 1.5 into 10 cube tons is 108 into 10, 108 into 10 cube. And for gas, 18 into 10 cube therms, that is the 3.6 into 10 cube. And electricity, 1 into 10 to the power of 9. Then the cost index is, what is the cost index? 108 divided by 1.5 and 3.6 divided by 18 and 22.5 divided by, sorry, 108 divided by 15 and 3.6 divided by 15 and 22.5 divided by 15. Directly we get. And the cost indexes are 7.2 and 0.2 and 1.5. If you want to get the percentage, then we can add all these 7.2 and 0.2 and 1.5. Similarly, we got the 8.9. And for individual, 7.2 divided by 8.9, 0.2 divided by 8.9, and 1.5 divided by 8.9, like that. And next, pie chart. Pie chart means this is the another representation of the representing our energy consumption. So several methods of the representing energy flows and energy consumptions are available, and most of these cases may be graphical or tabular. Most popular among them is a pie chart. So a pie chart is a circular chart divided into sectors illustrating proportions. So in a pie chart, arc length of the each sector is proportional to the quantity it represents. So it is an effective way of displaying the information, and pie charts works particularly well when the slices represents the 25% to 50% of data. And it has a disadvantage in comparing different sections in a pie chart or to compare data across the different pie charts. So these are the pie chart. So here individual part is known as the arc. So as the arc length increases, the commodity or the quantity of that particular object is very more like that. So here this can be very useful for the where the percentage lies between the 25% to 50%, then there will be a clear information. But what is the disadvantage? If this particular slide can be represented in a another way, that means this particular slice of the pie chart consisting of the further classifications, that means renewable energy is 8%. So in this renewable energy we have again solar energy, geothermal energy, and wind energy, and hydropower energy, and biomass energy. So these all are present in another manner. So among these 8%, the solar energy will be present as the 1% in the 8%, and geothermal energy will be present in the 5% in the 8%, and wind energy will be present in the 9% in the 8%, and the hydropower will be present in the 35% in the 8%, and biomass will be present as the 50% in the 8%. So if you represent all these in this slide, this pie chart will become somewhat difficult. So that's why the pie chart is more allowable pie chart, but this will be complicated when we go for the further classifications. That means inside classifications, then it will be becomes more complicated. So this is about the pie charts. So I already told about that. In this video, our discussion is cost index and energy index and pie charts and load profiles. Load profiles and Sankey diagrams. So what is meant by Sankey diagrams? So what is meant by Sankey diagrams means in the flow of energy flow diagram, nothing but energy flow diagram. So in our industries, different sources will be used for the our electricity will be flows to the different equipments, and how that electrical energy will be flows to the different sources, different destinations is can be represented with one diagram. The diagram is nothing but Sankey diagram. So here we'll let us see the Sankey diagram. So this is the Sankey diagram. So here we have electrical energy is 5 joules is there. So on these 5 joules can be used for lighting up one light, for lighting up the one light. Then 3 point on those 5 joules, 3.9 joules will be used for the thermal energy, and 1.1 joule will can be used for the light energy. That means in the total 5 joules of energy in the light, most of the energy will be converted as a thermal energy in the form of a heat energy. In the form of a heat energy, only 1.1 joules only can be used as a light energy. So how these 5 joules will be transformed to in different ways, which represents this operation is nothing but Sankey diagrams. So here a Sankey diagram helps to show how light and heat energy is produced. So here 500 joules of electrical energy is there. So in those 5000 joules of electrical energy, 425 joules of heat energy will be wasted, and only 75 joules of light energy can be useful by us. Then the efficiency is equal to 75 divided by 500 into 100. That means 15% of energy will be useful energy, and the remaining 85% of energy is the wasted energy. So more complex examples. Typical energy splits in gasoline internal combustion engines. Different engines, the Sankey diagrams are looks like in this manner. So the various Sankey diagrams proposed by our government of India and for the various operations, these are the Sankey diagrams. So next our topic is load profile. So what is meant by load profile? So what is meant by load profile? The demand charge is often is a significant component of the electricity bill. Effective demand management offers sustainable savings opportunities. The demand profile for a facility, building, service entrance, or any user of the electricity is simply by record of the power supplied at any point in time. To the electrical energy auditor, the demand profile is an extremely useful tool in tracking the energy use. So here this is a graphical demand profile. So this is the tabular demand profile. So here for every hour how much demand is there. So at 1 a.m. 45 kilowatts, 2 a.m. 47 kilowatts, and 3 a.m. 43 kilowatts, and 4 a.m. 46 kilowatts, and 5 a.m. like that. This is a table for the 24 hours. Table for the 24 hours. And by seeing this profile, load profile, we can simply understand that how much where we have the maximum demand and where is the most electricity requirement, like that. So the information derived from the demand profile is peak demand, night load, startup, shutdown, weather effects, and loads that cycle, and interactions, occupancy effects, and problem areas. So peak demand, the time, magnitude, and the duration of the peak demand period or periods may be determined. And night load, the demand present at night is clearly identified. And startup, the effect of the operation startups upon the demand and the peak demand may be determined. Shutdown, the effect of the amount of the load turned off at shutdown may be identified. This should equal the startup increment. And weather effects, the weather of The effect of the weather conditions upon the demand for the electricity can be identified from day to night and from season to season by comparing the demand profiles in each section. And loads that cycle, the duty cycle of many loads can usually be seen on the demand profile. This can be compared to what is expected. And interactions between the systems may be evident. For example, the increased demand for electric heat when ventilation dampers are open. And similarly, occupancy effects. Often the occupancy schedule for a facility is reflected in the demand profile. If it is not, this could identify control problems and problem areas. A short cycling compressor is usually easy to spot from the demand profile. So opportunities for savings in the demand profile are a peak demand that is significantly higher than the remainder of the profile for a short amount of time is an opportunity. A peak demand that is significantly higher than the remainder of the profile for a short amount of time is an opportunity for the demand reduction by scheduling. So the peak demand is in very short time. So that is the opportunity. And an high night load in facility without night operations presents an opportunity for energy savings through the better control. So a high load in a facility without night operations. So that provides the best opportunity for the energy saving. And loads that cycle on or off frequently during the unoccupied periods suggest that possibly they could be shut down completely. And a large load that cycles frequently may result in a higher peak demand and lower utilization efficiency than the smaller machine running continuously. And high demands during the breaks in a production operation are insignificant drops at breakdown times suggest that equipment idling may be costly and considered to be shut down. And make sure that systems are not starting up before they are needed and shutting down after need has passed. Even half hour per day can save a significant amount of the load is high. And peak demand periods at startup times suggest an opportunity for staged startup to avoid the peak. And for customers to build on KVA demand, there is an opportunity to reduce the peak or maximum KVA demand by increasing your power factor. And power factor correction saving opportunities are also there. So this is about the load profiles. So in this video, you see about the cost index, energy index, and pie charts and Sankey diagrams and load profiles. So with this, our first unit is completed. So we will see in the second unit. Thank you.